Okay, in this video we're going to be going through the first problem or two in momentum review number 1. So this is the problem right here. So the problem says we have a 700 Newton force that is being applied to a 300 gram block moving at 18 meters a second. It says this force is exerted for 45 milliseconds. So the first part, A, is asking how much does the ball weigh? So A is pretty straightforward in that it's really just asking what's the weight, what's the force of gravity. So the formula for force of gravity is the mass times the acceleration due to gravity, and that's going to be equal to, so what the mass is, it says 300 grams, but that's not in standard units, so we're going to convert that to kilograms. So 300 grams is going to be 0.300 kilograms times the acceleration due to gravity on Earth. We'd assume this is on Earth. That would be 9.8 meters per second squared. And then that's going to equal 2.94 newtons. So that's the weight. Again, it's really just one equation, the force of gravity equation. The second part gets a little bit trickier. I'm actually going to switch to a new clean sheet of paper. So this one, it's asking about where is it? It's asking about what is the acceleration, or no, if the force on the ball is in a direction opposite to the initial velocity of the ball, find the final speed of the ball. So again, we're looking for the final speed in this one, so a little bit different. So it might be helpful to draw what's happening. So in this one we have the ball, it's going one direction with some initial velocity. I'm just assuming it's going to the right. I guess it could go to the left, technically. And then there's some force being applied to it. Sounds like just an applied force. And then what's happening is ends up going the other way by the end. So it has a final velocity in the opposite direction. So it's asking us to figure out what the speed of this is. Yes, so the final speed of this. So the way to find this would be to use the momentum impulse equation. So what we have to do is find each one of these. So I'm going to expand it out a little bit. So this is really, this delta V, remember, that's VF minus VI. So delta anything is the final minus the initial value. So I'm going to start plugging in stuff. The mass is 0.300 kilograms because it says 300 grams, so it's 0.3 kilograms. The final velocity we don't know yet, but we do know the initial is 18. It's given as 18 in the problem. 18 meters a second. And then it's saying, well, this side, what is the net force? It tells us the net force is 780, and it's 780 in the direction opposite to the velocity. So if you assume the velocity is to the right, the initial velocity, we're going to assume that the force would be the left. So the way I drew it, we'd assume it's negative 780 newtons times the time. It tells you it's 45 milliseconds, so we convert that. That's going to be not even a second. That's going to be 0.045 seconds. So we're going to do the math out for this. It's going to be VF equal to, or scratch that, VF minus 18 is equal to negative 117. So the final velocity is really negative 99 meters per second. So that's pretty close, but it's asking for the final speed. Yep, the final speed. So what we want is we want the we want the velocity, but we want it without the direction, any indication of direction. So the speed would be the same number, but it would just be without the negative. So it would just be 99 meters per second. So that would be B. The next one would be C. So C says, what is the acceleration of the ball during the collision? We get a new sheet for that. So C, what's the acceleration of the ball during the collision? So we know this is really kinematics. So we have some information about this. We know the initial velocity is 18 meters a second. We know the final is ultimately negative 99 meters per second. That was just calculated in part B. And we know that the time is 45 milliseconds, or 0.045 seconds. So we have the initial velocity, final velocity, the time. Great. So if we're solving for the acceleration, we can use a kinematic formula. This should be pretty familiar. And I'm just going to rearrange it slightly. So we solve for acceleration. I'm just going to move the VI over, divide by T, A. So at this point, I just need to plug in. So once you get to here, it's really just a plug in. So the final velocity is negative 99. The initial velocity is 18, right, minus the 18, and divide by the time, and that's going to be a lot. It's going to be negative 2,600 meters per second squared, which is the standard unit for acceleration. So again, pretty large. There's a pretty large acceleration on the ball when it's being acted upon by that force. So that is part C. The last part D, is saying by what factor would the velocity change if the force applied to the book was doubled. So again, I'm going to do this on a new sheet of paper. So again, it said what would the change in velocity, what would happen to the change in velocity if you doubled the force applied to it. So again, this is really, you have to really, you can do a lot of math and plug it back in and solve it. It's probably easiest to solve this using proportionality. So we need to relate the change in velocity to the net force. So the one way to do that, well, yeah, really the only way to do that is with the impulse momentum equation, right? So what we have is we want to relate delta V to the net force. So we're just going to rearrange slightly so we get the change in velocity by itself. So what's happening, we want to figure out the multiplier first for the change in velocity. So the multiplier, we'd replace we'd replace the net force with 2 because it's double. We replace time with 1 because we assume it's not changing. We just replace the mass with 1 because we'd assume it's not changing. It didn't say anything about changing mass. So the multiplier is going to be 2. So that means if we double the net force, so if we double the force that's being applied to it, we're really going to double the change in velocity. A little sloppy, let me rewrite that. So again, we double the force, we're really going to double the change in velocity. Okay, so that was, let me go back. That was all of the parts for problem number 1 in the Momentum Review 1.